Welcome to Frank Stajano Explains. Today's topic is this book, Introduction to Algorithms by Cormen, Leiserson, Rivest and Stein, or clrs. How did a young MIT graduate student end up putting his PhD on hold to write one of the most popular computer science textbooks of all times? As the fourth edition of this classic hits the bookstores, let's hear the story from the horse's mouth. My distinguished guest today is none other than the C in CLRS, Professor Tom Cormen. Like, subscribe, and share this interview with all your geek friends. Hello, it's a pleasure to finally meet, at least over video, Professor Tom Cormen, the legendary author of the Introduction to Algorithms, of which I have here the third edition. It's a well-thumbed book that I've been using to teach my own course for a while. And we are speaking today because you're going to introduce us the fourth edition that has just come out. I have never.
Fact, I have it.
You have it in your hands.
Have it right here.
Oh, very good.
You can see my ring light reflecting in it. Yeah, yes. So this is an advanced copy, and it should be available, at least in the US, first week of April.
Yes, I've been chasing up the release date, which keeps moving slightly, but I hope to get my own very soon. Now, what are you most proud of among the various changes that you made to produce this fourth edition?
I guess it would be that there's a chapter on bipartite matching algorithms. And the reason I'm proud of that is I had to learn all three of them just to write the chapter. One of them, the Hopcroft-Karp maximum bipartite matching algorithm for an unweighted bipartite graph, we had as a problem in previous editions, and I had to flesh the whole thing out. We have the stable marriage problem, which I probably had seen years ago, but I had to learn the Gale-Shapley algorithm. And then for the assignment problem, we have the Hungarian algorithm, which I probably learned when I was a junior in college, which would have been 1977. Amazingly, I didn't remember it, and I had to relearn that and then write all these things up. So that chapter took quite a bit of effort on my part just to learn and then to write up and make up exercises and problems. So I was pretty happy about that. Another thing that I'm very happy about with the new edition is I did a lot of rewriting. And in particular, we tried to make the writing more personal, a lot less we, and a lot more you. So talking to the reader rather than using what I call the we crutch. As an example, we in previous editions might have said, next we delete the node. Well, you know what? We're not deleting the node. Maybe the procedure's deleting the node. Maybe you are causing it to be deleted, but we're not deleting it. So there's a lot of rewriting that way. And another place where we rewrote, it doesn't come up all throughout the book, but we made the language gender neutral. And as an example, no more traveling salesman problem. It's the traveling salesperson problem. And there was one place where we could not fix that. And that is when we talk about binary tree structures and we talk about a parent's sibling. The English language does not have a gender neutral term for aunt or uncle. So we stuck with uncle. We apologized for that in the preface and in the first use. And I've since heard terms like pibbling, but we didn't use that.
That's interesting. So when you do this kind of change, is it like, I imagine, I presume that one of the four was primarily responsible for one chapter, one for another, and so on. Is it like one of you takes on the responsibility for doing all the we become you throughout the whole book, or everybody does it for their own chapter?
So I am not only the first author because of alphabeticalness, but I'm also essentially the project manager. And of the four authors, I'm really the only one who went through the entire book for the fourth edition. For the earlier editions, we all went over everything, and that really ensured a nice uniformity. For this edition, my co-authors were all pretty busy, and I was on the verge of retiring, so I had a lot more time. So I went through the whole book. So that rewriting in terms of the using second person instead of first person plural and the gender neutral language, that was really mostly me. That said, I'm not trying to say that my co-authors didn't do anything on the fourth edition. They did plenty. But in terms of ensuring uniformity of writing, that was me. And also, I got to always give credit to our copy editor, Julie Sussman, who is just the best. And she caught a lot of things in terms of not just the technical, but the writing as well.
Has she been in the partnership, so to say, from the first edition?
Oh, yes. Yeah, well, for the first edition, she didn't copy edit, but she wrote the instructor's manual, which was a snapshot of the algorithms course that Charles Leiserson was teaching back in 1991, I think it was. And Julie found a bunch of errors in the book. So we felt like we should get her on board as a copy editor. So for the second, third, and fourth editions, she was our copy editor, as well as for the other book I wrote, Algorithms Unlocked.
So she's an employee of the MIT Press?
Not an employee, but she does work for them, I guess, as a contractor. But she worked directly with me. So our way of operating was that I sent her PDFs of the various parts. She printed them out. She marked them up. She scanned them and then sent the scans back to me. And there were many places where I needed to discuss with her comments. Either I needed clarification or I disagreed with what she was writing. And in virtually every one of those instances, whether or not we were correct, it meant that we had to make a change. If Julie is having trouble with it, even if it's right, there's got to be a better way to say it. And in many places, she had better ways to say things and some restructuring. I mean, she's really the best.
Well, having a good copy editor really makes a difference. I mean, I know from my own small scale experience. And I notice when I see books that didn't have a copy editor, you can spot that.
Oh yeah, yeah.
Anyway,
I also,
I'm sorry.
I was just going to say, I also find just having co-authors really helps in that regard. So when I wrote Algorithms Unlocked on my own, I remember seeing a quote from Jeffrey Ullman, who's written, of course, many computer science texts. And he said that when he wrote alone, he would get caught up in his own craziness. And I found that was true with Algorithms Unlocked. And Julie was a really good check on my own craziness then.
I'm curious, is her background in the English and arts, or is she a computer scientist?
Her background's technical. She's an MIT alum. And she's married to Jerry Sussman, the co-author of Structure and Interpretation of Computer Programs and a longtime MIT professor.
All right, okay. Good, so I guess an answer to the question is, why is this fourth edition coming out? Were there things in the third edition that had become obsolete? Were there things that new things that had happened that you felt had to be in the book and were not in the book? Or is it just that basically every successful book needs to be refreshed every once in a while, otherwise it won't continue to sell?
All of the above. So, so the previous edition, the third edition, came out in 2009, and this 13-year gap between editions is the longest gap that we've had between editions, other than the semi-infinite gap between the 0th and the first. So the first edition came out in 1990, the second in 2001, the third in 2009. So, we felt that it really was time for a revision, just in terms of the clockwork. But of course, that alone is not a reason. Other reasons, yes, there was material that we wanted to include. There was material that we found people were not teaching, and that was a candidate for removing. And everything we removed will be put up on the web on the MIT Press site. There was even a chapter that we added in the third edition on Van Emdenbosch trees that we found actually people weren't teaching, so we've removed it. And why remove things? Well, we had a contractual limit. So our contract for both the third and fourth editions specified a maximum length of 1,312 pages. And that includes front matter. For the third edition, the length was 1,312 pages. For the fourth edition, we came in much shorter, 1,311 pages. So we really had to think about, if we're putting in new material, what's got to go? So we had to take some things out. And in terms of the new material that we wanted to put in, yes, there were some things that we really wanted in there. And probably the most important one is a new chapter that I didn't work on as the primary author, on machine learning algorithms. And Rivest and Stein were the primary authors on that. There's a section on clustering, there's a section on multiplicative weights, and a section on gradient descent. And Ron and Cliff were the primary authors on those, but I spent many hours going over those and improving them and finding things that were unclear. And then, of course, Julie had her hand in it and found all sorts of things that I missed. So yeah, it was a matter of getting some new material in there. As I mentioned, the chapter on bipartite matching. We have some new sections. There's a whole new section on suffix arrays in the string matching chapter, and a very long extended problem on suffix arrays. And that leads me to another change, which is we wanted to put in new problems and exercises. And there are several new problems and exercises. I forget the exact number, but quite a few.
So one thing that, I mean, I've used your book for many years, teaching first year and second year students. And one thing that would sometimes come up is you teach us all this stuff in a very abstract sense. Now, which one of these things are the ones that Google use, for example, when they do Google Maps and so on? So how do you feel about giving some perspective on the applications of all these things? Is there some of that in the fourth edition?
Okay, well, we don't always go into direct applications, but I mean, you brought up Google Maps. And of course, the classic use in Google Maps is an algorithm that is in probably every algorithms textbook, and that's Dijkstra's algorithm for shortest path in a directed weighted graph, right? So when Google Maps is routing you from point A to point B, based on various metrics, usually travel time, right? For every section of road, they have an estimate of how long it takes to traverse that section of road. And then they run a shortest path using that as the weight. And if you're using Google Maps in your car, it will periodically reevaluate and say, oh, here's a shorter route. So that's just a classic use of an algorithm.
So would, for example, Google Maps implement the Fibonacci trees in order to make the Dijkstra's algorithm go faster?
That's a good question. I don't know what they do at Google. And actually, you hit on one of the chapters that we removed because we've just found people were not teaching it. Yeah, I don't know whether they would do.
I've been teaching that for a while, and I got that question.
Yeah, I don't know if they use that or not. It's a good question. They might use something like Dial's algorithm instead, where they're actually just using buckets. I don't know exactly what they use. But just to get back to the application, in the chapter on single source shortest paths, we introduced the problem as driving from one place to another. I think in the third edition, we said driving from Phoenix to Indianapolis. And in the new edition, I gave a shout out to my hometown where I grew up, Oceanside, New York. And it's driving from Oceanside, New York to Oceanside, California.
Right. So I remember corresponding with you a few times for minor bug reports and stuff like that. And in January 2019, I sent you a small thing, and you said, well, I already knew about this one, but I didn't even bother putting it up on the web pages and errata because now we're winding down support for the third edition. We are working on the fourth. And you had already been working on the fourth edition for a while at that stage in January 2019. And it's now over 3 years later. So I bet that, I don't know, 5 years for working on a new edition is probably more time than it took you to write the first edition. Am I right?
Yeah, so the difference is for the first edition, it was 3.5 years, but really 3.5 years solid, at least on my part. And what your listeners might not know is that we did that while I was in graduate school. So the first edition was started and completed while I was still getting my PhD. In fact, we completed it 2 years before I completed my PhD, and that's one reason it took me 8 years to get my PhD. This new edition, actually, we worked on it for quite a bit longer than 5 years in terms of elapsed time, but it wasn't 5+ years concentrated. It wasn't that this was the only thing I did during that time. It was my main focus for the last, I don't know, 3 years or so, maybe less, I'm not sure. But I did work on it off and on well before that. Just as an example, in the summer of 2017, I was working with 2 undergraduates who were colorizing the figures, the illustrations, and also one of them was writing the Python code that we're releasing. And I'd worked on it before that too. I can think of some of the things that I changed well before that. So really, it wasn't just an intense effort the whole time on this edition. And same for my co-authors. And my co-authors, they had all sorts of things going on. So yeah, it's really hard to imagine how much time we really put in. I know for the first edition, I did a very rough calculation and I estimated 14 person hours per page. And for this new edition, I have no idea what it would come to.
14 person hours per page, that's quite something.
Yeah, my estimate there was we had about 1,000 pages, and then I estimated I put in 6,000 hours, and Leiserson and Rivest each put in 4,000. That was a very rough calculation. So you do the math, 14 hours per page.
Wow, that's impressive. So you hinted at the fact that you were a graduate student while you were doing that. Can you just tell us the story of how the first edition came out?
Sure.
How did you decide that you wanted to do a book as a PhD student? And
yeah, so what happened was I had a National Science Foundation fellowship when I got to graduate school, and that funds you for 3 years, and they don't have to be 3 consecutive years. And at MIT, you have to get a master's along the way to a PhD, and that usually takes 2 years. And in my case, it took 2 years. I did my master's. I wrote a master's thesis on switch designs of all things. And at the end of those 2 years, other graduate students counseled me, take the 3rd year off from the fellowship because you're burned out from doing your master's thesis. You're not going to get anything done in that 3rd year anyway. So that sounded like good advice. So I took the 3rd year off, which meant I had to be a teaching assistant or a research assistant. So in the fall of 1986, the beginning of my 3rd year of graduate school at MIT, I was the TA for 6046, which is the MIT Undergraduate Algorithms course. They now have one before that, but at the time that was the only undergrad algorithms course they had. And Charles Leiserson, who was my research advisor, was teaching the course. I was an extra TA for the course. I was what they called a course development TA. Bert Kaliski, who was Ron Rivest's PhD student, was the other TA. But my job wasn't to interact with the students as much as to go to the lectures. I would have Charles's handwritten notes, and then my job was to write them up in LaTeX and have them ready for the next class. And it was a Tuesday, Thursday class, so I had either 2 or 5 days to do it. At the end of the semester, Charles was just so pleased with what I had done that he suggested that we turn it into a textbook. And actually, I should take that back. He suggested we turn it into a lecture notes and computer science book. And that sounded good to me. And then somewhere along the line, it turned into a textbook.
Excuse me, was this course based on a textbook itself, or was it just based on these notes?
There was a textbook. It was the Aho Hopcroft and Ullman Design and Analysis of Computer Algorithms. That was the textbook that was, I forget if it was required or recommended, but the main material was the notes that I wrote up. But of course, they came out after the lecture because I had to go to the lecture, listen to it, and then write up the notes. So somewhere along the line, this lecture notes in computer science book became a textbook. And I do not remember how that happened. I don't, somehow morphed into that. And I didn't realize that we were talking about probably a factor of 5 difference in effort. Getting problems and exercises, the length of the thing, getting everything consistent, having great examples, all sorts of things. And then the other big change, of course, was Ron Rivest entering the project. Ron had taught the undergrad course. He was teaching the graduate course in the spring of '87. So Ron joined the project as well. And it took us 3.5 years. We were really trying to get things right. I remember as we were approaching the middle of the book and approaching the dynamic programming chapter, we'd already had several chapters where we had to make major changes as we went along. So when we did the dynamic programming chapter, I actually sketched out a pretty complete outline beforehand and ran it by Charles and Ron, and they bought into it. And I wrote the chapter exactly to that spec. And Ron and Charles looked at it and they didn't like it. And it wasn't, they didn't like how I wrote it. They realized, yeah, that structure, once they really saw it written out, it wasn't really the right structure. And I was somewhat upset. I'd put a lot of work into it. So we asked one of the PhD students in the theory group at MIT, would you mind taking a look at this chapter and telling us what you think about the structure? And he agreed with Charles and Ron. So we had to rewrite it. Or I should say I had to rewrite it. And then of course, Charles and Ron each made a pass over it. So it took a long time because of that, because we really wanted to get it right. And that's why it took 3.5 years. That, and then some of the tools we had at our disposal. The illustrations for the first edition were done on a Mac Plus. So one of those little Macs with the little black and white screen. They were done with Mac Draw 2 on a Mac Plus. And the whole book had to get indexed. And the indexing, as I recall, took 6 weeks. And that was even with 2 students going through and just identifying index terms and then using the software that Ron had wrote. Ron wrote this program called Windex that helped us organize the index. But it still took me 6 weeks to do the index.
What does the W in Windex stand for?
I think just because Windex is a product for cleaning glass.
All right. So you wrote up these lecture notes for Charles's lectures. What was this the first year that he was lecturing it? Were there no notes for the previous years?
There were, but they were sketchy. I'm trying to think how to say this nicely. People don't go to grad school in computer science at MIT because they really like writing and are good at it.
I see. Okay, so there was enough of a step change that Charles decided, okay, well, we could do something with those as opposed to the other ones.
Right.
So very good. So it's nice to hear in your own words the story of how this got started. I find it fascinating. I hope many others will as well. Now, if we look at it from the perspective of someone who might find this video and maybe is a junior academic, like a graduate student like you were, and says, well, actually, I thought that to write a book like that, you had to be some kind of big cheese professor, but this chap wrote it when he was still a graduate student. Maybe I have a chance at that. Maybe I could give it a go. So what words of advice would you have for someone who's considering writing a textbook as a graduate student? Is this a good idea? Is it something that just worked out a fluke for you, or is it something everybody should do?
I do not recommend it. As it took me 8 years to get my PhD, and really 3.5 of that was the book. In those 3.5 years at the end, the job market had really changed and it had gotten worse. I was very fortunate to get a job at Dartmouth. But in 1989, the job market was really quite a bit better. I would say that if you're going to be writing a book, it's probably better to wait until you have tenure, so that you can take the time to do it and do it right. We were fortunate. Our book came out at the right time. It was the right book at the right time, and the size certainly helped. There weren't 1,000-page algorithms books out there except the 3 volumes of Knuth. And our book really, it bridged a gap, and it was really the right book at the right time. People had converged on a model for algorithms, the RAM model. And of course, I think the quality of our book was a big factor as well. It's not just that we had a book at the right time. But yeah, I would say if you're in grad school, focus on getting your PhD and don't write a book.
So when someone finds the right moment in their own career to write a book, which may be later, as you suggest, and I would agree with your advice, especially to my own students, then at that stage, what's the secret sauce for making it a success? Is this the co-author you work with? Is this having a very original idea? Is this being the expert in the field? Is this finding the right publisher? Is this having good connection to the community so you get reviews early? I don't know. I have no idea. I mean, I have written a book and it has, it has had a very modest, how to say, spread. And it's been very nice for me in terms of putting me on the radar of other people who would then, consider me in the field. But it has not been a commercial success. It's been, I'm proud of it academically. It's nothing like that. So what does it take to make a book sell hundreds of thousands of copies?
Well, the first thing one of the things you touched on would be the first thing I said, which is co-authors. So, when I wrote a book on my own, as I said, I got crazy, and just having co-authors, and not just any co-authors, but Charles Leiserson and Ron Rivest, who are both incredibly intelligent and really good writers, and very open to working with a mere graduate student. So just as an example, we have a 50-page chapter in the first edition on number theoretic algorithms. And of course, Ron Rivest wrote that. And I remember I spent a lot of time reading that over. I have fond memories of sitting out in a park, reading it and marking it up. And I had ideas as to how to restructure some of the material. And I brought those ideas up to Ron, thinking, one very possible outcome is Ron says to me, look, you're just a PhD student. I am an expert in this area. We're going to do it my way. No, that's not what happened. Ron was very open to my suggestion as to how to restructure it. And in fact, that's what we did. So having co-authors who are really smart, but also don't put their ego into the writing, that was a huge, huge help. And of course, that they're good writers. That was just a really big help. What else would I say? You certainly want to try to present things clearly, and you have to choose a level. And we have a lot of mathematics in our book, and a lot of people don't like that. A lot of people, they see all the mathematics and they cringe and they just can't deal with it. And I get that. It's not really for everybody. And we don't intend this book to be for everybody, because there's no one book that is for everybody. But we also wanted to make sure that what math we had in the book was grounded. So we try to not just pull facts out of thin air. We do have some sections where we state some basic mathematical facts. We show how to evaluate summations. We explain some graph theory, some theorems. But the math is really quite well grounded in the book, and we really wanted to make sure that it was. So there's that. You mentioned the publisher, and we were very fortunate to work with MIT Press, which of course was about as local as a publisher could be. Their office was 1 block from where I lived, and it was between my apartment and the lab for computer science. So it was easy to stop there whenever I needed to. And also for the first 2 editions, the book was co-published with McGraw-Hill. And the nice thing about that was McGraw-Hill has a very large marketing department. So we had McGraw-Hill helping to market the book as well. For the 3rd and 4th editions, we chose to go with only MIT Press. And they've certainly done a nice job marketing the book as well.
So was this something where basically the MIT professors already had this thing, the default arrangement is if we do a book, we do it to the MIT Press, or was there a conscious choice of going to the various publishers and saying, actually this one, which happens to be next door, but it's actually the best of all the ones we surveyed, and we did survey half a dozen.
Yeah, so it's really the latter. So there was a path that was already set up. I think there was an MIT electrical engineering computer science series that already existed that didn't have that many books in it, but it did exist. But we actually talked to other publishers. We talked with, I think, 5 altogether. And in fact, one of the publishers we talked with, my wife was working there at the time, not in technical books at all. My wife was working on elementary school level foreign language books. But we visited that publisher, and the conference room that they had was off on the side of the cafeteria, which is up on the top floor. And I remember we were heading over to the conference room, and there's my wife eating lunch.
But you felt that the MIT was the one offering the best deal. What was the deciding factor for choosing?
So what we did, we actually did a quantitative analysis to choose a publisher. And this is a decision procedure that actually my wife and I used to decide to come to Dartmouth. And it's one that I teach to my students. And it's actually pretty simple. You make a list of the criteria that you care about. Just list every criterion you can think of. So in terms of our book, it would be proximity to the publisher, the royalty arrangement, the quality of the editorial staff. We just made a big list. I don't remember what else was on it, but quite a few things. Then you give each criterion a weight, some number, and just for convenience, make the weights add to 100, since we can think that way. Then for each candidate and each criterion, you give it a score between 0 and the weight of that criterion. Then you add them up. And then you iterate, right? So what happens is you say, all right, well, yeah, I think this particular criterion, yeah, I probably weighted it a little too much. Let me take that down a little bit. And this one I didn't give enough weight to. Let me take it up. And then you re-weight and you iterate until you are satisfied that you got it right. And the beauty of this procedure is you end up making the decision you were going to make anyway. But now you know why you made it. Because for any important decision, there are going to be times that you have second thoughts about it. And you say, why did I decide this? And then this gives you a reason to go back. Okay, why did I do this? So in terms of the decision that brought me to Dartmouth, I had another really good job offer, but it was at a government research lab. And really, in many ways, it was as good as the Dartmouth offer. But there was one thing that I wanted to do that I could not do at the research lab, and that was teach. So the times that I was not as happy at Dartmouth as I was at other times, I would remind myself, I'm here because I want to teach.
Right. Well, I love the bit about your procedure where you give yourself leeway to just go back and change the weights so that it fits what you really want.
Yeah.
Because we are humans after all, we're not machines. And so, yeah,
that's right.
It's as much as about figuring out what you really meant as taking a decision in an objective way.
Right. And not just what you really meant, but it's a way of realizing what's important to you.
I like it. Thank you.
Yeah.
Right. Well, I think if nothing else for time, we should be closing it here. What are your final words? Do you have any advice for either readers of your book or aspiring authors who want to follow in your footsteps, or whoever else you want to address?
For readers of our book, you might have to read things a few times to get it, because there is math, and the math is sometimes hard, but it's all there. So please try to take the time to understand it, and don't be afraid to get help from somebody else. One thing I find with a lot of computer science students is that they're sometimes reluctant to get help. So get help if you need to. And I would also say that for a lot of the algorithms, if you implement them in your favorite programming language, you will understand them quite a bit better. I mentioned Python implementations that my former student, Linda Shao, did. And actually, I did a bunch of them as well. And I really did find doing the Python implementations helped me really understand what was going on. And in fact, when I did teach algorithms, I always had a programming assignment where the students had to implement a dynamic programming algorithm. We found that implementing dynamic programming really helps you understand it. So yeah, I'd say don't be afraid to implement in your favorite language. And we will be releasing the Python implementations for reference.
Well, I want to thank you especially for saying that last thing, for endorsing what I tell my own students who will be watching this video. I always tell them, write the program yourself. It's the only way you will understand is if you write it yourself. And we've had discussions about which languages to teach in the Cambridge Computer Science course over the years. And at some point I pushed for Python, and there was reluctance to do that. That was quite a few years ago. But then I sneakily used Python in my notes to accompany the course to pretend that it was pseudocode, because it basically is at the same level of pseudocode. And I just don't call it Python. I just say, this is some pseudocode. Sometimes I write a piece of English in the middle of the statements, but it has enough disregard for all the formalities that you can pretend that you're just talking to yourself on how the algorithm works. And so I did not expect that you would say that, and I'm happy that you do, and it endorses what I already was telling my students, and I'm very happy that they now hear it from the master. Thank you very much.
Yeah, in my 27 years of teaching at Dartmouth, I taught our introductory course 25 times. And I taught it in 4 different languages over the years. The first time was in Pascal, then several years in C++, then about a decade in Java. And then around 2011, we switched to Python. And it wasn't my idea to switch to Python. It was one of my colleagues, Devin Balcom. And I was not happy with that idea. I was pretty happy teaching it in Java. So I resisted a little bit, but I went along with it. And I got to say, these days when I write code, for whatever reason, I'm writing it in Python.
And that's a good note on which to finish, I think. Right. Well, thank you very much, Tom. It's been really a pleasure.
Frank, online. It's been wonderful talking with you. Bye-bye.
Great. Thank you. Bye-bye.